Picture the Mariana Trench, Earth's deepest, darkest abyss, nearly 11 kilometers down, where pressure is 1,000 times greater than at sea level. Here, we drop humanity's most powerful weapon, the Tsar Bomba, a hydrogen bomb with the force of 50 million tons of TNT. Its 1961 test sent shockwaves around the globe and a mushroom cloud to the edge of space. But what if we detonated it at the trench's lowest point, Challenger Deep? The bomb, built for the sky, now faces the crushing weight of the ocean. As the countdown ends, we're not just setting off an explosion, we're igniting a sun in a world of eternal darkness. The question, how will the deep ocean contain this fury? On one side, the bomb's fission-fusion reaction, mimicking the sun. On the other, the Pacific's colossal mass pressing down. This isn't an open-air blast. Energy can't expand freely here. Instead, it's a violent, compressed struggle between human technology and the unyielding deep. The stage is set for a cosmic drama in the silent, crushing dark. Detonation is instant and silent to the world above. A nuclear chain reaction rips through the bomb, releasing energy that vaporizes the surrounding water in microseconds. A blinding flash, unseen by any eye, creates a superheated bubble of steam and radioactive debris, millions of degrees hot. This bubble expands violently, sending a shockwave racing through the ocean, detectable by seismic stations worldwide. Marine life would experience a deafening, disorienting blast, but the deep ocean pushes back. Pressure here is relentless, slowing the bubble's growth. In a second, expansion halts. The bubble reaches perhaps a kilometer across, huge but far smaller than an atmospheric fireball. The struggle is a tug-of-war. The bubble's internal pressure fights to expand, the ocean's weight tries to crush it. The initial blast wins round one, but as the bubble grows, its pressure drops. Soon, the ocean's force takes over, setting the stage for the next, even more violent phase. The explosion's fury is contained, but the bubble's life is just beginning. The deep sea's grip is unyielding. What follows is a battle of physics at the edge of human imagination. At its peak size, the bubble's expansion ends. The ocean's pressure now dominates. The bubble collapses, not gently, but with crushing speed, flattening and forming a high-speed jet of water through its center. This transforms the bubble into a turbulent donut-shaped torus. The collapse rebounds, reigniting expansion, but with less energy each time. The bubble pulses, expanding, collapsing, sending out weaker shockwaves. Turbulence tears it apart, fragmenting it into smaller radioactive bubbles. The ocean, when the bomb's energy is shredded and scattered. These hot, buoyant fragments begin a slow ascent toward the surface, carrying radioactive contaminants. The violent physics are over, but the environmental consequences are just beginning. Many fear a massive underwater nuke would unleash a devastating tsunami, but tsunamis are caused by huge shifts in the seafloor, not point source explosions. The Tsar Bomba's energy, though immense, is concentrated and absorbed by the deep ocean. The explosion creates a bubble, but at 11 kilometers down, its energy is dampened before reaching the surface. Instead of a towering wave, the surface would see a turbulent swell, maybe a few meters high, quickly fading. Dropping a bomb here is like tossing a powerful pebble into a vast pond ripples, not tidal waves. The real threat isn't a Hollywood-style wave, but the invisible radioactive plume rising from the depths. The ocean absorbs the blast, but not the poison. The danger is silent, spreading, and long-lasting. The radioactive bubbles reach the surface, releasing toxic steam and fallout into air and water. A radioactive cloud rises, some carried by winds, most dumped into the Pacific. Ocean currents spread the contaminated plume across thousands of kilometers. Radiation at the blast site dilutes, but low-level contamination spreads through the marine ecosystem. Plankton absorb it, small fish eat plankton, larger fish eat them. Radiation climbs the food chain. Top predators like tuna and sharks accumulate dangerous isotopes, threatening marine life and seafood supplies. The environmental impact is insidious, not explosive, but persistent and global. The unique life of the trench is wiped out instantly, a catastrophic loss for biodiversity. The bomb's roar fades, but its radioactive legacy echoes for decades. The ocean's currents carry the poison far beyond the blast. So, what's the verdict? We'd sterilize the trench, poison the Pacific, and disrupt the food web for decades. Yet, in planetary terms, the event is insignificant. No global earthquakes, no shifting plates, no change to Earth's orbit. The Tsar Bomba's energy, massive to us, is a blip to the planet. Earth shrugs off even the largest human explosions. Its systems are too vast, too resilient. Our greatest weapon is a flash against geological time. We can poison our world, but not destroy it. The real damage is to ourselves and the life we share Earth with. Nature endures, it's humanity that pays the price.